Hello everyone and welcome back. This week we want to see some concepts behind the training models. The first concept that we will see this week is the concept of loss function. So machine learning models improve by minimizing a loss function, which measures the accuracy of the model's predictions compared to the actual value. Means that when you want to define a loss function, you have some values which are estimated by using your model and some values which are given as the actual value. Comparing between these two will give us a tool, mathematical tool, which is called loss function. When the predictions differ significantly from the true value, the loss function yields a large value. It means that the values that you are estimating by your model, if these values are very different from the actual value, the loss function that you will get is very large number. To run an optimization problem, the loss function gradually learns to reduce the prediction's error. It means that our goal is to minimize loss function, and through the process of optimization, gradually we will make loss function smaller, and when we make loss function smaller, we can reduce the error. Choosing a suitable loss function for machine learning algorithm is not a one-size-fits-all approach. We will see this through the one example that finding that suitable loss function sometimes can be very tricky. Several factors actually come into play when selecting a loss function for a specific problem, including the type of machine learning algorithm employed, the ease of calculating derivatives, and to some extent the presence of outlier in data sets. We will see this stuff through one example in another video. Loss functions can be broadly categorized into two main types based on the learning task at hand. As we had before, in machine learning, there are two different tasks. We have regression task and we have classification task. Therefore, we will define regression losses and classification losses. In classification task, the objective is to predict outputs from a finite set of categorical values, as we had this before. For instance, given a data set of handwriting digits image, as we explained before, this data set is called means. We will see more about these data sets. The goal is to categorize them into one of the digits from 0 to 9, because here we have the data set which consists of handwritten digits 0 to 9. And the goal is to classify them into 10 classes. And regression task. In the regression task, we want to predict the continuous value. For example, given a feature such as floor area, number of rooms, and size of rooms, the aim is to predict the price of a room. So we will see some examples of these two different cases. For example, for the classification losses, one of the most important losses that we have is cross-entropy loss. If this formula looks a little bit tricky, don't worry about this. We will see that we never use this formula, but I just wanted to show you that how this loss function is defined. Then here I want to explain about YKI. YKI here belongs to 0 and 1. And these are the target probability. And here, as you can see, this YKI hat is our prediction. Then here, as you can see, we are taking the logarithm of this prediction, and this prediction that we have here is a value between 0 and 1. And that's the reason that we have negative here. We have m classes here, and we sum these over m classes, and these YKI are the values which are given. If k equal 2, it means that the classes that we have here is just 2. It means that we have a binary classification, and for the binary classification, this loss is called logistic regression loss or logistic regression cost function. So m here is the number of data sets, the number of data points that we have in the data set, and k is the number of classes. We have other losses which can be used for regularization. One of the most important one that we had at the beginning of the semester is MSE. In the MSE here, as you can see, yi hat is the value that we are predicting by the model, and yi are the values which are given. Then by finding the difference between the actual value and estimated value, we can find the error. But since we do not know that this yi minus yi hat is necessarily positive, then we take a square. And after that, we will add this for all data points that we have. Another way that we can make them positive is taking the absolute value. When you take the absolute value, in this case, you can define this loss. This loss is called mean absolute error. So, as you may remember at the beginning of the semester, we had the concept of Euclidean distance and Manhattan distance. As you can see, this in MSc, we are using the Euclidean distance, and in MAE, we are using the Manhattan distance. Thank you.